D'Alembert ratio test. If summation un be positive term series such that limit n tending to infinity un plus 1 divided by un is the finite number L, then summation un converges. If L is less than 1, diverges when N is greater than 1, and test fail if L is equal to 1. If summation un be positive term series, then we get this, which we already discuss the convergence of the series. This is the general term un. This is un plus 1. We find this ratio, and after simplifying this we get 2, which is greater than 1. That's why this series is divergent. For the next, this is general term. This is un plus 1. By replacing n by n plus 1, we get this ratio n tending to infinity, and we see that this value 1 by 2, which is less than 1. That's why the given series is convergent. Now test the convergence of this next series. This is the general term, x to the power 2n minus 2, even number power, and n plus 1 under root n. This is un plus 1, n tending to infinity, un plus 1 divided by un. We get this x square, and by D'Alembert ratio test, this x square is less than 1, then series converges, and if x square greater than 1, the series divergence, and if x square is equal to 1, we find ratio. That means Vn. The process of finding Vn is the highest power of the denominator, that is n to the power 3 by 2, and the power of n is the numerator, which is 1, and this series is converges. Vn is converges, that's why un is also converges, and tending to infinity un upon Vn, which is non-zero finite number. Vn and un converges, that's why the given series is converges. For x square less than or equal to 1, and diverges for x square greater than 1. Test the series of the following. This is un, and this is un plus 1. We find the ratio, that is 1 by 2 less than 1. Then by D'Alembert ratio test, given series is converges. Test the convergence of the following series. Un plus 1 upon un, that is x. Everything depends on the value of x. If x is less than 1, converges. X is greater than or equal to 1, converges.